agreed to demonstrate step by step how the CIA team in this scenario would infiltrate the targeted building.
This is our subject's building. As you can see, we're out in the desert. Our primary objective is to dispatch the surveillance crews.
The crews would be set up in various areas, all in different proximity to the target. They would have to blend in with the surroundings to avoid suspicion. This scout team will collect any information that could prove useful for the eventual infiltration.
The surveillance procedure might range anywhere from a week to a month to several months. When the team is comfortable, they move on to their next step.
The next step is to figure out a way to defeat the locks used to secure the building. A procedure in which the CIA's World War II predecessor, the OSS, took its cue from the great Harry Houdini.
And as Houdini, it turns out, traveled the world, one of the things he did was buy an example of every lock that he ever saw, every key that he ever saw. And he studied in advance. If he was traveling on a promotional tour to England, he would carry with him an example of every lock and every key that was publicly in use. And he'd know the differences between keys used in the United States and keys used in England. And all of the thousands of escapes that Houdini had carried out, and the thousands of locks he had opened, he had never failed for one reason. Nothing was ever left to chance. And it was part of this methodical approach that the CIA adopted.
The type of locks used must first be determined.
They do another survey, and part of that survey may entail an individual going to photograph the face of the lock, or taking a special modeling compound, actually getting an imprint of the keyway.
And how that's done is there's a key impressioning kit that they will use. They'll take this plastic type modeling clay, it will press into the lock area.
The operative, with some feigned reason to visit, it could be the cleaning person, it could be the telephone repairman, it could be a visitor, would simply walk by the target door and take and press this into the keyway. An examination of this would determine the type and brand of the lock, as well as the size of key needed for the surreptitious entry.
Ideally, this mold would be sent back to headquarters, where an exact duplicate could be forged. However, depending on time and location, this may not be possible. Situations like this require the field officer to craft a key on his own.
So the challenge becomes, how can we quickly duplicate this key? For this purpose, going back as far as World War II, intelligence agencies designed a key casting kit, a mold that's filled with modeling clay. And the idea is, you'd open the mold, you'd take the key, press it in, put it between, and squeeze. And what you're left with is an exact replica of the key and the teeth. The next step, you would take a small thimble and you take a piece of a metal called Cerebom. And Cerebom is unusual in that it melts at temperatures as low as 120 degrees. And so with a simple birthday candle, you could heat the metal. Once it becomes molten, you would pour it into the mold. Once it's cooled off and dried, you'd simply open the mold, recover the molten key, take it to a master key, and file the master till it exactly matches the copy. A trained expert could accomplish all of this in less than 10 minutes.
With the proper keys created, the entry team is mobilized. Their first goal will be to neutralize the alarm system that prior surveillance has detected.
If the survey of the terrorist office shows that they've used a conventional hardwired alarm system, this type of kit was developed to defeat the alarm. And essentially, it exists to complete the circuit from the wires. This would be clipped in, and the two alligator leads would be placed on each side of the circuit. Therefore, the doorway that you targeted, once the lock was picked and it was opened, the alarm system wouldn't register that the door had been opened. This circuit would continue to send a signal, and the master alarm would think the door is still closed.
As technology has advanced, so has the sophistication of alarm systems. Each system must be thoroughly analyzed in order to effectively defeat its unique warning signal.
It is our job in the laboratory to see if we can defeat the alarm signaling process. For instance, we have an alarm panel here, and what we are doing, we're injecting a signal into the alarm panel, and we are determining what effect that has on the particular panel. We are trying to determine if by injecting a frequency, the effects it will have on this particular alarm panel.
Once a particular signal is determined to effectively disrupt the alarm's communication, the system can be defeated. Engineers are constantly working at seemingly unconventional methods in order to overcome increasingly sophisticated alarm technologies.
Often, electronics are used, chemistry is used. For instance, as we speak, one of our scientists is working on a device using a chemical, liquid air, to help defeat electronic circuitry.
Engineer Chet Storust works as a consultant on special